So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 24 of the April Daily Leetcode Challenge and we have an easy question in front of us. It's question 1046, last stone weight. Okay. So in this question we are given an input array of integers. It's called stones and let us see what the question demands from us. Okay. So each element in the stones array represents the weight of the ith stone. Okay. So for example, 2 is the weight of the zero stone with zero index. Okay. That is the basic idea here. So we are playing a game here on stones, and what they are saying is, see, for example, this is my stones array, right? Now select these largest and the second largest stone means in terms of weight. Okay, select the largest and the second largest stones in terms of weight. In this case, it will be 7 and 8. Okay, so we are playing a game here, and I'm going to tell you how it works. Okay, so we will at each see it. We will take multiple turns here, and in each turn, we'll select the largest stone and the second largest stone in terms of weight. Okay, in this case, it is 7 and 8. Okay, they are called x and y. Okay, in this case, y is greater than x. So if both of them have same weight, then both of them will be destroyed. Okay, please note this point somewhere. It's very easy question actually. If you follow this point, it will be very easy for you to understand the tracing of the examples. Okay, if both the see what we are doing, we are having a stone array, right? We will do some turns here till we are left with only one stone. Okay, so what we'll do is in each turn, select the largest and the second largest stone. For example, in this case, you can see 7 and 8 are the see 8 is the largest, 7 is the second largest. Okay, so what we'll do is if x and y both are equal. Okay, if x and y, for example, if 7 and 8 are suppose they were equal, then both the stones will be destroyed. Okay, both the stones will be destroyed. In case they are not equal, then we will remove both the stones and replace with a single stone which will be having a weight y minus x. I will again repeat. If the largest and the second largest stone, which is x and y, see they are referring to them as x and y. Okay, if x and y have same weight, then both of them will be destroyed. Okay, we will not replace them with anything. If they are not having the same weight, then both of them will be destroyed, but we'll be replacing them with a single stone whose weight will be y minus x. Okay, y minus x means the largest stone weight minus the second largest stone weight. That is the basic idea. I'll quickly show the tracing. You will understand that. Okay. At the end of the game, there is at most one stone left. So return the weight of the last remaining stone. If there is no stone left, return zero. Okay. Now quickly trace this example. You can clearly see that 7 and 8 are the largest stone. Okay. If we subtract them, which is 8 minus 7, in this case they are not equal, right? So we will replace 7 and 8 with 8 minus 7. Okay, we will replace 7 and 8 with 8 minus 7, which is equal to 1. Okay, so you can clearly see now there are three ones. Okay, this addition one came in place of 7 and 8, and remaining were as it is. Okay, these things are coming from as it is from this. Okay, only the addition one is this. Okay, because 8 minus 7 equal to 1. Okay, now the largest and the second largest are 4 and 2. What is 4 minus 2? It is 2. So I will replace these two with 2. Okay, as you can clearly see here. Okay, what are the largest and second largest now? It is 2 and 1. So what is 2 minus 1? It is 1. So these two are replaced with a single one, which is 1. Now, which is the largest here and second largest? These are 1 and 1. They are same. Okay, they are same. This is the first time they are same. So both of them will be destroyed. Okay, these two will be destroyed, and we're left with only this one. Okay, we're left with only this one here. Okay, and when we're left on a single one, see at the end of the game, see this is we have to call it as the end of the game. Okay, the end of the game is when there is at most one stone left. So in this case, we have only at most one stone left. So we will end the game here. Return the weight of the last remaining stone. Okay, we have to return this weight, which is one. And this is the return. Okay. So in this case also there's one stone left. So in the starting of the game itself we'll end the game and we'll return one. Okay. And one important point about this question is that see the constraints. Okay. Here the maximum number of strings is going to be 30. So you can think of a end log n solution also, or maybe n square solution as well. Okay, this is not a big number. Okay, so if you're using see, definitely you will have to use sorting. Okay, let me give you a hint as well. If you have to do this question in a proper approach, then my solution advice to you will be use priority queue. Okay, that is the see priority queue is, this is like application of priority queue. Okay, this example is like application of priority queue. But you have to simply solve this question because the constraints are very low. Then you can do it any way you want. Okay, you can go up to n square solutions. Okay, time complexity wise n square. So let me show you what solution I have coded. Okay, so this while will be done till the length of the stones is greater than one. Okay, That means if the stones number of stones are two or more, then this value will be entered. Okay. What I will do is first I will solve the stone. Okay, then I'm putting the stone. I am calling x as the second largest stone, y as the largest stone. Okay. In Python, when we say stones of minus one, it means the last stone. Okay. And similarly, when we say stones of minus two, it is the second last stone. In Python, it's like this. Okay. So x is the second largest stone, y is the largest stone. If both of them are equal, I am popping both of them. See, stones dot pop minus one means it will pop y initially. Then x will become the last stone. So I am again doing stones dot pop minus one. So in this, after these two operations, both x and y will be popped out. This is what they are seeing here. Okay. So both x and y are equal, both of them will be destroyed. If they are not so, if they are not equal, what will happen? I am replacing the second largest stone with y minus x. Okay, and I'm popping the last stone. Okay, what I'm doing, I'm like replacing this second largest stone, which was x actually. I'm replacing that with y minus x, and I'm popping the last one, which was y. Okay, see, the last stone was y. Okay, and the second largest stone was x. Okay, I'm replacing x with y minus x. Okay, and I am popping out y. That is the basic idea here. Finally, I'm playing the stones again when we come out of this loop. And these are the else conditions which I can see. That is what they have told here. That can be, see, if there are no stones left, return 0. If there is only one stone left, okay, return the last stone. I'll quickly run and show you this. I will again trace the example one with my code. Okay. So yeah, as you can see, this is a given input to us. Once we start, like once we are doing the sorting in end log in time, this is going to be the sorted array. Okay, so you can clearly see x is going to be 7 and y is going to be 8. They are the second largest and the largest one. Okay, so what we'll do is we'll replace 7 and 8 with 8 minus 7. So you can clearly see this one is coming extra. Okay, I'm including that one and sorting it again. Okay, so I'm getting this. In this case, 2 and 4 are the largest and second largest. Okay, so second largest and largest. So what we'll do, we will replace 2 and 4 with 4 minus 2, which is 2 here. Okay, so we'll replace 2 and 4 with 2. In this case, the what is largest and second largest? Largest is 2, second largest is 1. So we'll replace with 2 minus 1, which is 1. Okay. In this case, largest and second largest are same. Till now, they were not same. Okay. But for the first time, they are same. So what we'll do, we'll follow this condition. We'll remove both of them. So we are left with only one thing. Whenever we are left with only one thing, see this condition. Whenever the length of stones is not greater than 1, that means, see, if the length is 2, 3, 4 like that, then the value will be entered. If the length is less than or equal to 1, it will not be entered. So we'll stop here. And finally, we will return whatever is my last. Okay, we are returning the last element. In this case, there is only one element, so it will return. So we're returning 1. Okay, that was the basic idea here. So the solution nearly 80% faster. And if you want to compare the time complexity, it's time complexity and log n. Space complexity wise, if you consider in sorting, see, doing sorting also will require some time space. Okay, it's log n space will be required, so you can consider that if we need to force you to take that. But otherwise, as such, we are not having any space complexity. It will be constant space complexity. But if you consider space complexity required for sorting, then it will be log n. Okay, you can mention that during the interview. So that was all friends for today. See, there are definitely more the better approaches, but as I told you, you will always have to play based on the constraints. See, if this question comes in a like online challenge, then do not waste your time thinking of how to use priority queue and all. See, the constraint is very less. You can solve it with the unscore approach also. Okay, so just try to code as fast as possible. If the constraints are high, for example, if the stone length is around 10 power 5 or something like that, okay, then you would have to use the optimized approach, and at that time I will suggest you to use priority queue. So, as a homework for today, you can please try to solve this question using priority queue as well. How to use priority queue? The best way, see, in Python, it will be slightly difficult for you because there are no ready-made data structures, and in online solutions, it may not be available. If there is a data structure also, it might not be available. So, I will suggest you to use priority queue of C++. Okay, that's how its coding is being. See, something is better in some language. Okay, that is the basic idea. If I have to code it priority queue, I will definitely use C++ only. You can search for it in the STL library. So yeah, friend, that was all for today. If you have any doubts, please do comment below. Yeah, thanks a lot.